Hello and welcome to the Enterprise Excellence Network webinar series. Today we are joined by Dr. Jeffrey Leica together with Professor Peter Hines. And today Jeffrey will be giving an executive overview on the Toyota Way through a scientific approach. Just before Dr. Jeffrey Leica begins, I just wanted to give a bit of background into the network for those who aren't familiar. So the network is a members-only arena for senior lean leaders based in Europe, and the workshops are held quarterly at best practice host sites where we have Gemba tours, and this is all led by Professor Peter Hines, and at the moment this is all turned virtual. But for more information on that, you will receive an email with our website address and an email as a follow-up to find out more. So today there'll be a 30-minute presentation by Dr. Jeffrey Leica, and then there'll be an opportunity to ask questions for around 30 minutes at the end, which Peter Hines will also chair. Okay, so now I will hand over to Peter just to give a bit more background into the webinar. Thank you, Peter.
Great, thank you very much, Emma, and hello to everyone. Good morning, good afternoon, good evening, whatever time of day it is with you. It's very nice to have you all with us, and it's my great pleasure to welcome Jeff Leica to be running our session today. So I think Jeff's one of the people in the lean world that needs very little introduction, so I won't go into his history of I don't know, about 55 Shingo Prizes and so forth. I think he's up to something like that. And but what Jeff's going to do is share with us some new insights he's had since first writing the Toyota Way book. And so the new version is going to come out depending on which part of the world you are in the next few weeks. And he's going to particularly pick up on the scientific management area that is quite a focus in the new book. So Jeff, with that, I'll hand over to you, and then we'll do a Q&A in half an hour or so.
Okay, thanks Peter, and thanks Emma. Appreciate the opportunity to share with you what I'm currently most excited about, which is the second edition of the Toyota Way. The reason I wrote the second edition was because I've learned more. It's been over 15 years, and I've learned more, and I have worked with a lot more companies, so I have a lot more examples of companies that are, in my view, doing lean the right way, and from both manufacturing and services. So I have more examples from both in the book outside of Toyota. But also I was heavily influenced by Mike Rother, who was one of my former students. He was a master's student in industrial engineering years ago. And he kind of went off on his own, and he was always at the Gemba and getting his hands dirty and learning by doing. And he was getting frustrated that all the great things he did while he was in a company, when he would come back in a few months, would largely be gone or deteriorated. And he came to the conclusion that the only way for lean to stick is to teach people to do it themselves in management positions. So if you're managing, say, a machining shop, the person managing that shop needs to be in control of improvement, understand lean concepts, and be able to work toward their goals. He also came to the conclusion that if you look below the surface at Toyota, what is really special is that every leader thinks scientifically. And I'm going to define what that means. So his conclusion was he has to teach people in his clients to think scientifically, which means changing their mindset, not an easy thing to do. And then he tried to figure out how do you change mindset, and he drew on other skills that we learn when we learn how to cook or we learn the martial arts, and he came across in the martial arts this idea of kata, which are small routines that you practice over and over again until they become natural and you don't have to think about them. And the goal is to naturally start to think scientifically. So I'll talk about all that. So that's why I put Toyota Kata and the Toyota Way together. So the Toyota kata and scientific thinking is throughout the new version of the Toyota Way. Let's start off with going back to the source of Toyota and
Jeff,
their
do you
Toyota
want
Way.
to?
Yeah.
The slides are not advancing.
Oh, they're not. Lovely. It's advanced on my screen, and you can. What do you see?
We still have the first slide.
Okay. This happened the other day. And since I don't know the software, I'm not exactly sure what to do, but is the slide advancing now?
Yes, it's not on slide share,
Yeah, but I
full
can do
screen,
that.
but yeah.
Yeah, okay. Well, thanks for pointing that out. Okay, so this is you can see now the Toyota Way 2001 house.
We can, it's not on full screen, but we can see it.
Okay, well, we'll do the best we can. Okay, so backing up. So the Toyota Way 2001 house came out before my book. I looked at it and it influenced the original Toyota Way. The purpose of this house was to make the principles explicit for overseas operations. And by that I meant that in Japan, the feeling within Toyota was that the Toyota Way was very natural, and it was just the way they did things. And they all started in the company when they got out of school, and they stayed till they retired. And when they joined the company, they just acted the way everybody else did. So it was the culture. So the question is, how do you transfer this culture to overseas operations, which are not unlike your operations in that there's just people from a country, India or Russia or England, and they don't know anything about the Toyota Way, and their culture is their culture. So the Toyota Way 2001 was to represent the culture and then to teach and develop the culture over time. And the two pillars they came up with are continuous improvement and respect for people. You can see the continuous improvement is purple, and the three foundational items to that underlie continuous improvement are, first of all, you need a challenge. And in Toyota, every leader has a challenge, from the team leader on the shop floor to the president of the company. They all have their annual challenge that's based on a 3-year business plan. And the challenge is big, bold, and seems impossible at first. The way you approach the challenge is through Kaizen, which is systematic step-by-step improvement. And the basis of Kaizen is always go to the Gemba, go and see the actual condition, learn at the Gemba through experimenting. So many people think of continuous improvement as being small changes that incrementally improve, say, the work site. But within Toyota, continuous improvement means everybody's working to improve all the time. So if you're at the top, your challenges are really big. At the top level of R&D, it's to make certain improvements to research and development for the whole world of Toyota. So that's big. And they will set very challenging, big objectives. And if you're in the middle, for example, you're a plant manager in the UK plant, then your challenge might be to launch a new product like they did in the UK recently when they launched the new Corolla. And their goal was to be the best launch in the world by all the standard measures of timing and cost and quality. So that was a big goal for the top. And then each shop general manager had goals aligned with that. They were very challenging. And then if you're a group leader and you have a certain number of workstations on the assembly line, you have to make improvements in cost, quality, and safety, and and productivity, and you have a bunch of targets that are, I would say more modest than the top and the middle. The point is that the bigness of the change has to do with the goal, how big the goal is, not the method used. The method is still the same. You start with a challenge that gives you the direction, and then through going and seeing, and at the Gemba, Kaizen, which is running experiments. So a lot of experiments quickly, you learn your way to the small, medium, or big goal. And challenge, Kaizen, go and see and learn reflect Toyota's model of scientific thinking. So what is scientific thinking? And I spent a lot of time talking to Mike about this. That's Mike and I. And we spent a lot of time talking about what we mean by scientific thinking. And Mike was pretty adamant that scientific thinking is not, yeah.
We're not getting the slide advance again. We're still on the house. Yep, that's it. Okay, can you put it on full screen?
When I put it on full screen, then I can't advance it.
Oh, okay. We'll leave it like that then. Okay, thank you.
This is the first time I said I've used this software, which is okay. So you can see this slide now, Peter?
Yeah, we can see the slide with you and Mike. Yeah.
Okay, good.
Yeah.
Okay, so anyway, Mike's conclusion was that he doesn't mean the scientific method. He doesn't mean that you're trying to be a scientist, and what scientists are trying to do is to create general laws, principles, prove them so that they can be deductively applied to anything. So they want a vaccine, which will work for anybody in the world in any condition. What the practical scientific thinker is doing, the kind of people like us who are trying to improve processes, is we're trying to use a scientific approach, a scientific way of approaching our challenging goals. And Mike refers to that as a mindset, a way of responding to goals and problems by first acknowledging that our comprehension is always incomplete and maybe even wrong. So we have to be humble enough to admit that we don't know everything. We have to assume that if we want to know whether our ideas work, we have to test them rather than just discuss them in a conference room. And we have to appreciate that there's differences between what we predict and what actually happens, and we can learn from that and make corrective adjustment. And I like this little slide by Prakar where he says, how do we define scientific thinking in one character? And it's just a question mark. So the idea is to have curiosity and to investigate rather than implement. Okay. So what we're really trying to do with scientific thinking is not implement lean tools in order to get results, but rather learn our way to our goals. Scientific thinking is a way of navigating unpredictable, complex territory toward our goals. In other words, we know where we want to be. We have a direction. That's a challenge. We know where we are because we've studied the Gemba and understood the current condition. And we know what we would like to accomplish and maybe what tools we think we might want to use. But we also believe that between us and the challenge are a lot of surprises. The territory is not clear. And we're going to go in there with a compass because we want to keep on knowing that if we're in the direction or not, if we're moving the needle in the direction we want. But every time we try to implement something, we're actually running an experiment to overcome an obstacle, and a lot of the obstacles surprise us. So at NUMMI, apparently one of their expressions was, there's no GPS in TPS. You can't predict and control where you're going to go. You have to find your way. So I've incorporated scientific thinking right into the center of my revised 4P model. In the original book, the 4P model was a pyramid. And now I made it a puzzle, and the idea is to show it as a system where all the parts connect to each other. And the 4 Ps are the same, which is philosophy, which I now call long-term systems thinking. And it's very important that we understand the nature of reality is systemic and things interact in complicated ways, and we can't always predict how they're going to interact. And that's one of the reasons we have to discover our way to the goals. The process I've defined as not a thing like a material thing that you're changing and modifying like you would, say, updating your software, but rather the process is a concept. It's a theoretical construct. This is what we'd like things to look like. This is how we'd like them to work. And what you're actually doing is struggling to flow value to each customer. So your ideal in Toyota's case is 1-piece flow, pure value added, to get the customer what they want, when they want it, in the amount they want. And do that ideally instantaneously. So that's impossible in most cases, but that's a vision. And to get from where they are to that vision involves struggle. It's not easy, and that's because they're moving through this zone of uncertainty. And who is it who can think deeply enough and be creative to go through that struggle? And it's only people. It's not computers. It's not even artificial intelligence. It's people. So because people are the key to continuous improvement, process improvement, achieving goals, they're respected, they're highly respected, they're at the center of everything. And respect for Toyota means not that you're going to have a nice, easy time like you're in a country club, but rather you're going to be challenged to think deeply, to persevere and keep on experimenting and work really hard so that as you improve processes, you're growing in the process. And the key skill for people is problem solving, or I'm now calling that thinking scientifically to improve toward a desired future. Now, scientific thinking makes sense, and most people have learned management by fact, say from Toyota, and they pretty much know, this is what we want to do. Unfortunately, more people think they're doing it than are really doing it. So the problem is that as humans, we naturally desire to get from the problem to the solution as quickly as possible, and we have a variety of biases. And what we mean by biases are that we assume we know things we don't know. We assume we understand cause and effect relationships that we don't understand. We retroactively decide that what we did was exactly what we intended and it worked out just like we intended. So we kind of confuse reality with our desire for certainty and knowing. And our brain is actually not as capable as we think it is. For example, we can process 11 million bits of information every second, which is incredible. But our conscious minds, the reasoning part of our minds, can only handle 40 to 50 bits of information a second. So we have to figure out what bits of reality to pay attention to and act upon. And the way we do that is to take shortcuts through templates, through oversimplification of reality, and it's based on these biases. These biases, like seeing something and stereotyping, this is danger, deciding it's danger, is based on a tiny percentage of all the information we have available to us. And it's actually necessary if we want to survive in a lot of circumstances. For example, you're driving your car and there's a lot of traffic and there's confusion, and you don't want to stop and try to analyze every single movement that you make. You have to react based on existing habits, routines, and assumptions about what's happening around you. So that leads you to surviving, and that's actually the key skill we needed hundreds of thousands of years ago. was fast reaction to survive. Now we talk about things like scientific thinking. We would like something different. I thought I had the slide, but you may have read the book, or at least be aware of the book by Daniel Kahneman called Slow Thinking and Fast Thinking. And he talks about making decisions based on these biases, based on these routines, as fast thinking. We quickly jump to a conclusion. We quickly jump to a solution. And the scientific thinking way is slow thinking, which he says is not our natural default. So how do we make scientific thinking more natural? We don't want to give up on fast thinking because we need it for lots of situations that require immediate reaction. But for the cases where you have time to reflect and think, how do we make scientific thinking more natural? And that's what Mike Rother came up with in Toyota Kata, which is that he found that any complex skill, whether it's learning to play chess or learning to the martial arts or learning to cook, requires practice. Everybody's come to the conclusion you can't become the best violinist in the world, even if you have natural skill, without deliberate practice. And deliberate practice means, number one, we have a model. We know what we want to be doing, what we should be doing to get the result we want. And we then do something and notice the gap between what we do and the model. And then we make adjustments to reduce that gap and get closer and closer to the model. And that's what the karate black belt is doing when they ask you, punch this way, and then you do it wrong, and they correct you and they correct you, and then they tell you to do it over and over again. And finally, at some point, they say, okay, now we're ready to learn the next skill. And each of those skills in karate are called kata. And you practice them exactly the way the instructor tells you to, or shows you, over and over until it becomes so natural that you just do it that way without thinking. So what Mike concluded is that he needed two things to make this work. One is he needed a model. This is what you should be doing. And then he needed practice routines. What do you practice at each step in the model? And he also noticed that it's hard for most people, say, to learn karate or to learn to be great cooks on their own just by reading a book or using YouTube video. That there's tremendous value in a coach that's giving you corrective feedback. So he built into his process a coach. So the model is very simple. It's simpler than most 7, 8, 10-step problem-solving methodologies. And it's not intended to be a problem-solving methodology at all. It's intended to be a pattern that we practice until it feels natural. And step one is we have to know the direction. Again, we want to navigate with a compass, so we have to at least know where true north is. And that it starts with a challenge. And once we know the direction, then we can ask, where are we now? What's the current condition? And now we are bound by the result we want and the starting point. And in between, we need to find our way through the obstacles that we often can't anticipate. So this is the uncertain territory. And to get from 2 to 1, we're going to define intermediate goals, which Mike calls target conditions, and they will have a date. So I want to get a 10% productivity improvement for my challenge. I'm going to start with a 0.5% productivity improvement by balancing the work in this bottleneck area. I want to have balanced work in this bottleneck area within 2 weeks. And I'm going to assume that I don't know exactly how to best balance the work, and I'm going to find out through running experiments, through trying things and learning my way iteratively to balancing the work in this one area. At that point, I'm going to ask, what's my next target condition for the next 2 weeks to get to my annual challenge? So this becomes the iterative learning process, which reflects what they are teaching and doing within Toyota, even though this is not Toyota's model and they don't necessarily think about it this way. But when they look at it and they see people using it, they say, oh, okay, I can sort of see that. That kind of makes sense. The practice routines are in the Toyota practice guide, and for each step, he gives you guidelines on how to do it, how to set a target condition, how to understand the current state, how to run experiments. And again, the goal is to practice each step, ideally with a coach. And his advice is try to do it every workday, at least for 20 minutes. And the goal is to practice the scientific mindset by behaving in a certain way, by actually doing it, by actually understanding, for example, the current condition and doing it, and then getting corrective feedback. And then as you do it in the better way, the more scientific way, your brain starts to change, develop new neural pathways, and you begin to think that way. You begin a new set of neural pathways that will cause you to think scientifically in the future. So the more you do it, the more you behave scientifically, the more you'll think scientifically, which means the more you'll behave scientifically, and you'll start to get this virtuous pattern. And the role of the kata are to start you off, and they focus on behavior. Do this in this way. And when I saw this, the reverse of this is also true. The less you behave scientifically, the less you'll develop scientific mindset, the more likely you are to conclude that you know everything and that you just need to implement your solutions, and you'll go backward. And it reminded me of my guitar teacher. I play classical guitar, and I take a lesson every week, and Nelson cringes when I play something wrong and then keep playing, because he says, Jeff, every time you play something wrong, you're getting better at playing it wrong. You're more likely to do that again in the future. So his goal, he says, stop at that point, slow down, very slowly play it correctly several times in a row. If you can do it 5 times in a row, then you can move on. And this is the definition of deliberate practice, which is not easy. It's not easy for me. I'd rather just make the mistake and play it through and say, oh yeah, occasionally I make a mistake, no big deal. And when you're performing, you need to play through your mistakes. But for practicing, you want to stop, correct, practice over and over again until you start to get this new pattern etched in your brain. The coaches also have a kata in Mike Rother's method. And what they're doing is asking questions that parallel the improvement model. So you ask, you're the coach, you're asking the learner, what is your target condition? What is your actual condition now that you're starting with? Then you turn the card over and then you ask, what was the last experiment you ran? What did you plan? What did you expect to happen? What actually happened? What did you learn? The idea there is to think about your idea for improvement. I want to move this workstation 3 meters closer to this other workstation. And what I expect to happen is to reduce inventory and reduce waste. So the cycle time is going to go down by 3 seconds. This is what I expect. And then you want to rub that expectation up against reality when you do it and notice any gaps. And then what did you learn from that? And then that will lead to your next experiment. So what we're trying to do is, instead of pushing lean tools onto a workplace, we're focusing on the problems we have specific to that workplace. What are we trying to accomplish in that workplace? What are the specific characteristics, the current condition of that workplace? And what are the gaps between where we want to be and where we are? And then to reduce that gap, we're actually pulling improvements that can include some of the lean tools. So it's useful to understand the lean tools, and there's knowledge to be gained by learning about Kanban and learning about how to set up a cell. There's a lot of technical information that you need to learn. But then when you, instead of assuming every problem requires a cell, you're looking at the actual situation and pulling the right idea to that situation and adapting it to that situation. So what we're really doing is solving not a generic class of problems, but rather this problem right now. And I have some examples below. One of the companies we work with is a mail order company. They mail order high quality, like gourmet food. And they've been at Lean for over 15 years, and they have all the tools. But when COVID hit, they first thought they had to shut down, and they didn't because they're mail order. But they had to space properly and use proper PPE, and they had to clean the workplace. Turns out every 2 hours they had to clean each workplace, and they had to space people so they couldn't fit as many people in the workplace, so that hurt their production, how many items they shipped per day. So there are a bunch of challenges. The way they met the challenges were all scientifically. For example, how do you clean the workplace? The manager of the shop people are busy just trying to get stuff out the door onto a truck to ship to customers. So the manager went and did all the jobs herself and figured out all the touch points and then develops initial standard work for each work area of how to clean it. Then she worked with the supervisors in the area to improve upon it, and they did experiments, and after 3 days, they had their cleaning method standard work specific to each type of job. So this was very natural to them because they had been practicing this for so many years. In summary, the essence of leadership at Toyota is, at a high level, respect for people and continuous improvement. These are the only two pillars for the entire company worldwide in information technology and sales and product development and supply base and manufacturing. This is what they want to be happening every place. People are treated with respect, which is challenged to grow, and they're continuously improving toward clear goals. They're not satisfied with deploying lean solutions. They want people thinking. And if you're just applying or copying something, you're not thinking, and it may not fit your situation, and you may not adapt it properly to your situation. And every company has your own unique situation, and you must identify your challenges and pull solutions to fit the problems you particularly face. The best way we know to do this is through scientific thinking, but it's unfortunately not our default mode. It doesn't come naturally. So we have to practice it. And everybody has to practice it from the top to the bottom. And what Mike did was to get us started with some starter kata, with some coaching that helps to rewire our brain to think more scientifically. And by doing this, you'll start to develop a common vocabulary, a common way of talking about problems, which is the definition of a culture. And the goal is to make managers coaches and not simply people who give orders and try to control things they can't really control. So this is what Toyota's doing. This is what Taiichi Ohno was teaching many decades ago. It's, again, natural in Japan. When Toyota goes overseas, they have to teach this, and they do this very deliberately all the time. So I'll take some questions.
Great, thank you very much, Jeff, for that. Very interesting. So if you'd like to type your questions in the questions box, and then we'll take the questions as they come. So we've got a couple of regular attendees to the webinar series who've already gone ahead and put some questions in. So we'll start with these, Jeff. That's okay. First one's from Stephen over there in Ireland. As managers, we are not encouraged to fail, which of course is where we learn most. How do we start to build an environment that allows leaders to understand that it's okay to fail as long as we learn?
Well, one way, not the only way, but one way is to use this kata approach I talked about. So what you're doing is you're bringing people to the gemba. And in the ideal world, you'd start with the CEO, the managing director. That doesn't always happen, but it would be ideal. And then what you're doing is starting with a challenge And it helps to start with a relatively repetitive, simple process. You're starting with a challenge, and then you're understanding the current condition, and then you're coming up with your first target condition, short term, this is what I want to accomplish in the next week or two. And then you're going to ask your learner, what is it you want to try first? And as you coach a person, you'll find that they don't fit this pattern well. They don't fit into the pattern well. So they say, well, we need to eliminate waste, and we need to create a cell, and we need standard work. And you're saying, they say, slow down, time out. What's one thing you want to try first? And well, I think if we just move these people closer together, they would be more productive. Okay, so you'd like to move these people close together. And what do you predict will happen when you do that? And then they do it. And then ideally, you don't want them to be right every time. And usually they're not. It's pretty rare that they are. So often what they think will make people more productive turns out to make them less productive. So they're experiencing the gap between what they assume will happen and what happens. And then you say, let's try again. Let's try another experiment. And you go through experiment 2. You know, what do you want to try? What do you expect will happen? What happened? What did you learn? As people go through this process, they discover that the world is a lot more complicated than they think, and that their assumptions are not always right. So now if I'm doing this and I do enough repetitions that it starts to make sense to me, then, you know, the goal is for me, say I'm managing director, to say, wow, all these goals I set for my people, and then just assume that they can achieve them, and I yell at them when they make mistakes. I had no idea. I had no idea what I was talking about. I actually want them to experiment like I did. I want them to learn that they're not always right, because that's how you learn. So I have to have a picture of what scientific thinking is, a visceral picture that I actually deeply understand to want to teach other people. And the first step is to realize the world is more complicated than I think, and that I'm not right all the time. And I can only come to believe that by experiencing it myself. And that's why he wants people to do something, because as long as they talk and talk and talk, they're always right. They know, they're all knowing, and they're always right. It's not until they actually test their idea and try it. So you see, for example, a managing director who's brilliant and seems always to be right, but they're always wrong when they're at home with their wife and kids. Because that's the real world. They're getting immediate feedback. But then they come to work and they're brilliant and they know everything. So you want more of a kind of experience they have when they stumble around in the kitchen trying to find a bowl and it's breaking eggs and it doesn't work right. You'd like that kind of experience to happen at work. So I realize I don't know as much as I think I do.
Sure, thanks so much. I was just sort of intrigued by Stephen's question and your response there, Jeff, that you know, a couple of things strike me. Is one is knowing what to do, but actually developing the mindset to want to do it as well, and getting that into the brain, and sort of building on sort of what you've given in your talk, the scientific thinking, the continuous improvement side. What's the science that fits behind the respect for people, and you touched on like the neuroscience in terms of how the brain works in order that we can get more scientific thinking. I'm just wondering whether there's some more thinking in that sort of softer side that might be interesting.
Side, number, what I want from a coach, what I want from my guitar teacher, which I'd like from my boss as well. One thing, I'd like my boss to know some things that are useful. You know, so if you want to teach me, you should know something useful to teach me, which means you have to go first and try it yourself. Second, I want you to be concerned about me and my learning and not showing me how smart you are.
Yep.
So if it's about you, then I'm going to get turned off pretty quickly. So if I'm the center and I'm your focus and you genuinely care about my learning, then I feel respected. And part of that is then you listen to me. And the kata model is that you don't give any answers to the student. The only thing you're responsible for is managing the process of thinking, managing the process of approaching the problem. So you want to make sure that I follow the steps and I get them right and I do it in the right way. When it comes to the ideas for how to change the workplace, that's up to me as a learner. So you're not giving me the answers, but and all you're doing is asking me to do something. Like, now we're going to look at the current condition. And remember, we talked about how to do that. And then I'm going to go off and do that. And then you're going to ask me, what did you learn? So all you're doing is asking questions, and you should be actively listening to my responses. And people feel really good when somebody actively listens to them, whether it's a psychologist or a manager. And then I'm going to struggle a bit, but if I run the experiments quickly, like it doesn't involve buying a robot and waiting 3 months, but it's something I can try today, then I can run enough experiments that I'm going to experience success as well as some failures, and I'll see the needle moving. I'll see my metric moving in the direction of the challenge. That's extremely motivating to anybody. That's why games are so popular. So all the elements of the kata, if you do them the way they're intended, will be showing respect for people. But you have to actually respect people enough to want to teach them, to believe they can learn, to believe it's valuable to invest in them.
Yeah, sure. Okay, thank you. Right, we have a number of questions. So let's go on to Willie's question here. So Willie says, what is your opinion about many organizations moving from the coaching role from line managers to lean managers? I know this is the case in Germany. Every factory does have a dedicated lean manager.
I think it's fine. I think the only question about the lean manager or the continuous improvement department or whatever you call it, the only issue for me is, what is their role? What are they supposed to be doing? And if they are responsible for meeting certain performance objectives to get a certain productivity level or quality level or on-time delivery level, if the continuous improvement department, or say the black belts, are responsible for getting these results, and they're going into the workplace with the intent of changing things to get the results, and they have a toolkit, and they're applying the toolkit of creating cells or statistically evaluating where there's variation and coming up with countermeasures. So in other words, if the continuous improvement person is doing all the thinking to get results, then I don't think you're gonna get sustainable change. On the other hand, if in the case of Toyota, someone like Ono or his students were all taught, don't give them answers. Your job is not to get results. Your job is to teach people in the workplace to get their own results. So if your goal is to develop the manager of that shop to reach that target, and therefore you're gonna need some extra time, you're gonna have to allow them to struggle. You may know the solution, or if you think you know the solution, maybe you're right, but you bite your tongue and you don't give away the solution. So that person might take a few weeks to get to where you could have gotten to in an hour, but you have the patience for that. So now the person has changed their workplace. They've been probably more thoughtful about it than you would have if you did it really quick and dirty. So it's probably better. And also they can continue to adapt because conditions are going to continue to change. So your solution, which might have worked perfectly this month, may be out of date in 3 months when demand changes, products change. So, the idea of you're teaching them to fish instead of fishing for them. So the continuous improvement department of lean leaders become coaches and teachers instead of the doers and implementers and the people who are responsible for the results. The results are the responsibility of the managers. This is my shop. I own this shop. I need to get these results. And it would be great to have help from a smart person, like a lean person, who knows some things that are useful to me.
Okay, thank you. So we have another question here from Lars. So Lars asks, In your experience, how do we best balance time spent studying a process to understand what needs to change and the time spent actually doing experiments? What the level of understanding do we need to start experimenting?
I would say the minimum amount of understanding needed to start experimenting, which is going to vary a lot. But in general, in the kata model, we're generally talking about maybe the first few days are understanding the current condition. And then, again, the next step is not to then jump to solutions or experimenting, but rather to then set a short-term target condition. So the point of the current condition is to allow you to set the target condition. So you understand where we are on the key metrics, and you've done some observations. So you want to observe cycles of work and look for patterns and good and bad things that happen. And when you see bad things that are happening, and you hypothesize that if I eliminate this walking waste, I'll get closer to the target, then you could set your first target condition, which is based on less walking waste. Then you will start to run experiments. Now, as you run experiments, every time you run an experiment, you're learning about the current condition and you're changing the current condition. So when you get to your target condition, you're going to ask, now what is my new current condition? So since you're learning more and more as you do things, as you act on the system and evaluate what happens, you don't need to understand everything up front. If I believe that I'm going to come up with a detailed roadmap for change with all my solutions in this current condition stage, then it's critical that I understand everything possible about the current condition and actually nail it. No, this is the root cause. This is the root cause. These are the changes I need to make to get to that root cause. And now I'm going to implement all those changes in parallel. 5 of us will go off and do in parallel implement a bunch of stuff quickly. But I will have wasted all that time if I didn't nail the root cause and get it exactly right. Whereas all I'm doing with this kata model is I'm saying, I just need enough to start to run experiments. And it's okay if I fail. And I'm going to spend less time per day on it. I'm going to run small experiments one by one and fail quickly, and then learn from that. And I'll be learning about the current condition. And as I do this, I might conclude my initial thought about the root cause is wrong, but it's okay. I have a better understanding of a different root cause that I didn't understand before. So your learning is growing about the current condition as opposed to trying to understand everything at once. So problem I've had with a lot of Six Sigma Black Belt projects is that they work their tail off to statistically analyze in detail everything they could possibly analyze every which way, and they're not doing anything. And the point at which you've analyzed all that data and information, since you haven't tried anything, since you haven't run any experiments, you have the least understanding you're going to have of the Gemba. So you're committing to solutions when you know the least.
Okay, thank you very much. Andrew asked quite a simple question. So that very interesting, Jeffrey. What do you recommend as the first step at the executive or senior management level to promote scientific thinking?
I would recommend that the senior management level do a project themselves. They become a learner first with a coach. So somehow you need to get the senior management to confront the reality of what they want to happen. I've been asked to bid on projects. I have a consulting company, and I've been asked to bid on projects where, because I work with Mike, I'll get some kata projects where they say we have 3,000 people to train in 3 months. Propose how to do that. They have no clue what scientific thinking is, what it involves, how you learn it. And they think that I could just sort of spray magic dust and suddenly people start to think scientifically. So they're not going to use a deliberate patient approach. The ideal way is to start small with a small number of people, ideally at the top. And then as people learn themselves and they start to think more scientifically, then they learn to coach others, and it grows organically, where 2 people becomes 4, becomes 8, it keeps on. So you get the exponential growth, but you're starting small and usually in one area. That's very unacceptable to a lot of companies that want quick deployment and quick results. So you can't really understand the value of starting small and slow, being patient, unless you've personally gone through it. So for example, Toyota's version of the Toyota Kata is called Toyota Business Practices. They started with the president of the company and then the executive vice presidents, and the executive vice presidents worked on a project for 8 months before they then started to coach the next level down. So, and it took years to get this through all of Toyota globally. So that's the mindset ideally you would have.
Okay, thank you. So a question here from Tim. I like the comment that the single character summary is a question mark. I'm interested in your reflection or experience of the cultural impact of asking why. Why positive, but why could also be negative too. For instance, how could you let this happen?
Well, okay, so this kata process is very controlled. So you're never in a position where you'd say, why could you let this happen? You're just following the model. That this is the next experiment. What did you predict? If the person runs the experiment and says, I predicted I'd get a 1% productivity improvement, but actually productivity declined by 1%. As a coach, you're happy about that because they're learning something. Then all you want to know is, what did you learn? Now, if you do that enough times and you develop the scientific way of thinking, then you would think it was kind of dumb to walk into a workplace that you know very little about because you're not there every minute of every day and say, this problem happened, why did it happen? And number one, you're placing blame instead of trying to understand what actually happened. And in scientific thinking, you want to know what happened, not who to blame. And number two, the person you're asking may not know. They know it happened, but they haven't done an analysis to understand the root cause. So they probably will give you an answer that's wrong. So again, as you learn things scientifically, you'd think, why would I ask that? Why would I ask why it happened? I might ask them, do you have a way to investigate what happened and why? That might be a good question.
Okay, thank you. So there's a question here that follows up on the Six Sigma point that you were making earlier, saying, I was a Six Sigma black belt before working on lean. Do you think that the Six Sigma approach adequately teaches scientific thinking? Do you want to say any more about that?
Well, I think that what I've discovered is that there's almost as many flavors of Six Sigma black belts as there are master black belts. In other words, who teaches you and how they teach you. So the scientific process, as I defined it, was simply that I assume I can't know everything in advance. And I assume that I'm going to learn by testing my ideas at the Gemba. So I've seen a lot of black belt projects. And these are, young kids often who are really good in math, and maybe they have their MBA, and they do a project and they have 30 PowerPoint slides that show normal distributions and where they're going to set their target, and variation across shifts and variation across men and women and variation across different tools that are used. So they've analyzed the data every which way, and then they've come up with their solutions. They found the root cause, they think, they come up with their solutions, and then they implemented their 5 solutions, and then they get certain results and they report out the results. Based on Mike Rother's model, and the model explained about scientific thinking, that's decidedly unscientific. They picked a few solutions, and usually from a lean point of view, if they're working on a project that you know something about, like say it's a changeover project, you know that there's another 50 things they could have done that would have made a bigger impact on the changeover time. But they picked these 4 or 5 things. And they implement them and the changeover time reduced. Great. Went from 4 hours to 2 hours. Well, I'd like to get it to 10 minutes. So what a person who's trained in Lean is likely to do is go to the Gemba, start investigating, not measure everything possible and not analyze the data from every which way, but they're likely to be doing things and trying things within the first hour on the shop floor. They'll naturally start running experiments. So within a few days, they can learn more than this. And I've seen this particular project of changeover time that took about 4 months, and the person cut the time in half. And they spent most of the time analyzing the data and most of the time proving they were right, and very little time experimenting. So that's not scientific. Now, a good master black belt probably would not let that happen and may well be teaching scientific thinking where you're using the data to understand enough so that you can then run experiments rather than trying to just understand the data all at once and find the answers all at once. So it depends on how you approach the black belt, but most of the black belt projects I've seen have not been very scientific in this definition.
Okay, good, thank you. So question here from Jim over there in Calgary in Canada. Jeff, what would you and Mike recommend for a coach when a performer is just starting? To go to Gemba with the performer or to brief before and after with an appropriate set of questions?
Okay, so Mike developed a storyboard, a visual that has the target condition, challenge, current condition, an area for the experiments, an area for obstacles you identify. And your coaching sessions are in front of the storyboard. And what you're doing, and you have the card at first until you learn enough, you don't need the card anymore, but you have the card at first, and you're just simply asking questions of the learner. Now, the learner is going to leave then with an assignment, that session. The assignment might be to collect more information. The assignment might be to run the experiment. And then they're going to come back to the storyboard, and they're the ones controlling the storyboard, writing on it and explaining it to you. Now, from your point of view, there may be value for you to go to the Gemba yourself. And in fact, a good coach will go to the Gemba and understand as much as possible before starting the project, because you have to pick the project and you have to pick the challenge. And then you're going to go back and look at what the person has done. But you don't have to do that with the person there. You don't have to watch everything the person does. You're just trying to understand the condition independently of the learner, so that when the learner is talking to you, you know what they're talking about, or you know if they don't know what they're talking about, if they say they did things that they really didn't do. So you're doing your own investigation, but the coaching itself happens in front of the storyboard.
Right, okay. Thank you. So time's a bit against us, but let's just take 2 more questions if we can, Jeff. So the first is from Gina. How does kata differ from the agile approach, or does it differ at all?
Yeah, so people who are agile or using the agile approach have found the kata very useful. So I wouldn't say that the kata is different from the lean approach or the agile approach or the Six Sigma black belt approach. It's really coming at this from a different angle. It's saying, given that you want people to do this, like follow this agile methodology to create software, say, they will be more successful if they think scientifically, if they approach the software development in a scientific way. How do we get them to approach software development in a scientific way? By giving them an opportunity to practice scientific thinking. In a sense, it's offline from the software development, or you're doing a software project deliberately using the scientific approach so that people get experience, learn by doing it. But it's really, that's why they're called starter katas, to get you started. Now, if you got to the point where it started to become fairly natural to think scientifically, you could put aside the kata completely. You might want to practice occasionally, but then you're just doing software development. And maybe you're following the agile approach, but you're doing it more scientifically. You're not jumping to conclusions, you're testing your ideas, you're getting input from other people like the user. It's natural to do that because they know things you don't know and you need to know. So it's really a way of creating a mindset so that any of these tools work, or you use them more effectively.
Great. Okay, so final question is from Simon, who says, what do you recommend to manage the different pace of learning, in particular, if a leader is learning less quickly than their team?
Yeah, so that's a problem. Actually, Toyota had that. Interestingly, Toyota had that problem at NUMMI and several of their first sites in the United States because they had hired workers and team leaders and group leaders at the first management level. And the group leaders were hired with college education often, and the team members and the team leaders were working at the Gemba, and the group leaders were in meetings, and the team leaders and team members, the production workers, were learning faster than the group leaders. Ideally, the group leaders would have worked their way up, maybe been team members, then team leaders, then group leaders. So it's a difficult situation. I think the important thing is, and other people I know in Toyota, like for example, a person I greatly respect, who was a general manager, was in assembly, and she was assigned to the paint department, and she knew much less than anybody about paint. In fact, she didn't even know where it was in the factory because she didn't have to walk by it to get to assembly. So she had to first find out where it was, and she was controlling all paint. So her approach was, I need to go to the Gemba and learn what these people know, and they're going to be my teachers. So she went to the workers and said, I need you to teach me how to paint. I need you to teach me how to repair the paint. And at first, everybody was like on pins and needles, worrying, is she going to screw up these cars? And can she do it? But she was a pretty quick learner, and they were really impressed that she was learning and listening to them. That allowed her to then understand where the weak points are in their training and in the way they managed. But she spent about 6 weeks just learning and being the student of the people who reported to her. And they didn't think less of her for it. They, in fact, came to respect her and feel like they're part of a team.
Great. Okay, good. Well, thank you very much for that, Jeff. Time's against us, as I said. So thank you very much for the presentation, and thank you very much for answering the questions there. So I'll hand over to Emma to close us down for the day.
Okay, thanks, Peter. Thank you very much, Jeff, for a brilliant presentation. And thank you, everyone, for attending. You will receive the webinar recording in the follow-up email, as well as a certificate, and also a link to our website for our future webinars and details on how to find out how to join the network as well. So yes, thank you, everyone, and take care. Thank you.
Okay, bye, everyone.
Okay.